2D and 3D unified data structure, right? So that these two major components can be integrated. At the moment, we don't see this kind of solution within the commercial. Could be in ArcGIS, could be in Bentley, could be in, you can name it. You can list down, it's not available, right? So we try to work out the approach so that we can have nice topological definition with 2D as well as 3D. Okay, so this is the, you can have topological based on geometry. For example, you have geometry table, and then you can add your topological table, something like that, as you can see on the slide. And then if you have more, then you can develop further using the same approach. And then of course you can still develop the appropriate table or proper link with those topological information. And then of course you can go further if you have more information. Okay? So we think that this is flexible and easy to work with other available data structure. And then the next thing is to visualize what you really want within your topological information. You need to view it. You need to view it, how your navigation propagates within another point to another point. Yeah? So this is one of the problems that exist today. We don't see this solution at the moment with the commercial. So we would like to test our approach or data structure within our good friend from Istanbul, Vintage. So we're going to get this data set from Vintage Istanbul to test our 2D and 3D unified data structure. For example, if you have something like this, how to connect your floor with your road network. Right? So this must be done. So our test area in Istanbul, hopefully we can get the data very soon. And then, so this is the overall view of our concept when it comes to 2D and 3D unified data structure. This one can be extended into underground objects. For example, if you have utility or pipeline within underground, it can be tested. So we're going to work with the Vintage very soon. The potential application, for example, utilities, 3D navigation, 3D cadastral, and then of course indoor network navigation ready kind of application. These are things that I discussed with you a few minutes ago with the underground. So in this case, we plan to test using Princess Island dataset, right? Just close by Istanbul city. I think the dataset contains DSM, building LOD2, plus underground DP. I think gas pipeline, right? Served up with the gas pipeline. Okay, so I hope this 2D and 3D unified data structure sort of trigger the new concept of linking 2D objects with the 3D objects within one system and one database. There is no separate. Yeah? We're supposed to avoid separate database, 3D database and then of course 2D database. That's what at least what happening in our country, in Malaysia. So we try to solve this problem for the mapping agency. So I think with that note, I would like to thank, of course, my PhD student is not here. Then I have to thank my Malaysian mapping agency for the data set of the LADM project, 3D LADM project, and of course to Vintage Istanbul for the data set that we initially received. Okay, so I think with that, thank you very much. I can take one or two questions. Yeah, June from ITU Istanbul.
Thank you for your visionary presentation. Also, I would like to add another dimension to your presentation. Okay, we have problems with 2D, 3D geometry. That's in our pocket. Maybe we try to geometry modeling of this in one way. But another problem related to semantics. And you mentioned land administration domain model, okay? And the first keynote presenter mentioned the city GML, different level of details. Also indoor-outdoor connection, indoor GML, for instance. And where are we going actually? There are different information models, and you mentioned the interoperability, one of your slides. And let's look at the bigger picture. Mapping agency, cadastre agency, other agencies, using the different models. Maybe geometrically, we acquire data spatially coming from the same sources like LiDAR, photogrammetry, etc. But semantic perspective, how we combine using the different domain models and they are related to each other. The bigger picture, we are talking these days very commonly smart cities, building information modelings. And most of the people express that without the spatial data and spatial model, smart cities will not exist. Then we have different domain models, we have geometry, semantics, but how can we reach the smart city by combining these different models? And what do you think about these issues? Thank you.
All right, thank you very much for your good question, I would say. I think we need to have a very sort of general or generic kind of data model that can serve various data sources as well as other applications. So the middle part, you have data, right? Then you have application. The middle part, the data model must be generic enough to capture all those questions that you raised. Your question is very valid. Now everybody try to do in pieces, right? But I think in the very near future, we should have that kind of generic data model. Right? Is that answer your question?
The answer will be valid in the near future, where we see the common integrated framework.
Yes, thank you. Yeah. 2 days before I came, there was a discussion between University of Melbourne group on land administration with the Malaysian data provider as well as mapping agency. They want to see what is the best way to move forward to have this smart city for Malaysian scenario. Right? So your question being discussed, basically, I would say valid, and it's not easy to have. It's not a one day or overnight kind of solution. Okay. Good question. Yeah, Professor Umid.
Yeah, thank you very much for this informative and very nice presentation. Very honored to have you here, as always. We were discussing with Professor Sadat as well while we were listening to your talk, and I'd like to ask if you have any initiative for the web services, 3D future services, and using web services as an integration platform for cadastral information, because all we're talking about is unifying all the information in a single database or single data source. So do you have any web services initiative to actually integrate information?
Okay, good question, Professor Umid. Basically, we have not really on 3D, not in 3D cadastral, but GIS in general. So we develop a web service for our own national data infrastructure center for Malaysia. For example, if someone would like to have data from this agency, and the agency can sort of communicate, right? Say, look, we have this kind of data. So that this kind of web service. It is not in 3D cadastral, but data set in general. I'm not sure whether that's answer your question. Yeah.
Thank you, Professor. I'm a computer science researcher, and how can we use this third dimension for applying on computer science domain?
Okay.
at which application areas, what can we do in the third dimension?
Yes, okay, all right. Thank you for the question. I always tell my students, in order to have good 3D or GIS research output, we need to work together with mathematicians, computer scientists, and geometricians or surveyors, if you like. So these three things, these three groups need to work together to produce fantastic kind of solution for our, for us, right? So we need your expertise when it comes to modeling, algorithm, to make things faster, yeah? Because, many of us as a users, they don't want to wait to get a result 10 minutes. You press the button now, you are going to get result next 10 minutes. No. Today we want to press the button, get the result within next second. That, in order to answer that, we have to have groups from computer scientists to improve computing performance, database search, etc., etc. Yeah?
For that, my study area is cloud computing. Maybe it could be an option to instantly to real-time production of the results.
Yeah, cloud computing also one of the good options.
Yeah.
Yeah, in order to for the so that you don't need to have physical kind of storage. Yeah.
Thank you very much.
Okay. Any other question? If not, then I sort of end this